So for this lesson, we're going to talk about slope. And slope happens to be a number that represents a line steepness. So slope is a number that represents the steepness of a line. Okay, and then we tend to call really slope rise over run. You might have heard that before. And if you think about the rise and you think about the run and you're on a coordinate plane, the rise tends to happen up and down the y-axis, and the run happens to go left and right across the x-axis. So when we talk about the formula to find the slope, which whose variable is m, the slope is given when given 2 points is represented as the change in the y's over the change in the x's, and change means difference of or subtracting. So in order to find the slope when given 2 points, you're going to do the change in the y values divided by the change in the x values. Some people, textbooks most often, tend to write slope as y2 minus y1 over x2 minus x1. It does not matter which point you start from as long as you're consistent, and again, the y's have to go on top. Okay, so what we are going to actually start doing is find the slope of the line given 2 points. And if you want, it might be helpful to label those 2 points. The first point, the -1, is the x, and this 2 from the first point is the y. That's why it's going to be x1 and y1. And then the second point, 3, 5, the 3 is the x, and the 5 is the y. Whoopsie, y2, not y5. Okay, so then what I would suggest that you do when you start setting up slope is kind of give yourself a skeleton formula or a skeleton ratio, and just do the m equals fraction bar 2 minuses, one top, one bottom, and then start dumping in your values. So on top, the y values are 2 and 5, the x values are -1 and 3. Then when you do the math, you get that 2 minus 5 is -3, -1 minus 3 is -4, and you always want to simplify your slopes. So really, double negatives give you positive. The slope of those 2 points would be 3/4. On number 2, again, if you want, label your points x1, y1, x2, y2. Set up your ratio. And then on top, 4 minus -2. On the bottom, 1 minus 3. When you do the math, don't forget double negatives. It becomes 6 over -2. And in this case, your slope is going to simplify to -3. Feel free to put a -3 over 1 if you want, or just leave your slope as -3, and that's fine. This time I'm actually going to go from y2 to y1. It does not matter which way you go, but I'm going to go from y2 to y1 for no reason, just to show you that you can still get the same answer. So I would actually take y2 minus y1, x2 minus x1, do the math, and you'd get 0 over -6. Now remember, 0 on top of any number is okay. It just simplifies to 0. So this answer is just a plain old 0. When I do the slope of this next one, I'm going to go from left to right. I'm going to do -2 minus 3, 4 minus 4. And this time this comes out as -2 minus 3 is -5, 4 minus 4 is 0. And remember, it's never okay to have 0 on the bottom. No way, not allowed to do it, which means this slope is undefined. Can't fit that in there. But this slope ends up being undefined. Okay, can't divide by 0, not allowed to. So it's not 0, it's no slope. So it turns out that if you think about some lines and their slopes, whether they be positive or negative, that if you were to take a look at a positive slope would be a line that rises from left to right. If you have a negative slope, it would be a slope that falls from left to right. In other words, let's do this real fast. So that would be a positive slope rising from left to right. This would be a negative slope falling from left to right. If you've got a horizontal line, your slope is 0. So those kinds of lines have slopes that are 0. If you have a vertical line, the slope of the line is going to be undefined. So that's going to look like that. Below is a painting by the artist Sol LeWitt. He uses each of the above types of slopes in his painting. Which quadrant represents each slope? So if you think about the quadrants, right, and it goes from top right all the way around, this is quadrant 1, this is 2, this is 3, this is 4. Well, in 1 you see a horizontal line. Horizontal lines have slopes that are equal to 0. Quadrant 2 has vertical lines, and vertical lines have slopes that are undefined. Quadrant 3 have lines that rise from left to right. So all of these things have positive slopes, and quadrant 4 in this painting has lines that fall from left to right. So the slopes of the lines in his quadrant 4 are all negative. People also talk about slope being the rate of change. Okay, and the rate of change, again, is still going to be the y values over the x values. If you take a look at this first example, the table shows the cost of a gallon of gas for a number of days. Find the rate of change with respect to time. Okay, so time is always going to end up being your independent variable. So time is your independent variable, which is always going to be your x value. And then your dependent variable, whoopsie. And then your dependent variable is going to be the price per gallon, which is your y. So what's happening from time, you should notice that as it goes from day 1 to day 3 and day 3 to day 5, we happen to be increasing by 2 days each time. And then if you look at the price per gallon over those 2-day increments, it turns out that the price per gallon goes up 10 cents each time. So because slope is the rate of change is the y value over the x value, we now have that the price of each 2 days, a 10 cents increase per every 2 days, means that really the rate of change is going to be 5 cents per day. Again, it's just the y's over the x's, okay? And time always tends to be the independent variable. Let's try it for the next one. This table shows the temperature whose change happens over time. Find the rate of change in degrees with respect to time. So in this case, the time, the independent variable, the x value happens to be on the bottom, and the y value, the temperature happens to be on top. And we always know that slope, rate of change, is always y's over x's. Well, if we look at the distance or the difference from the one temperature to the next over the 6-day period, each time we've got a constant rate of 5-degree increase. So that would be our top value. On the bottom, as we're going from time, I'm assuming this is in maybe, I guess, hours. I don't know for sure, but it's increasing by 2 each time. So assuming that we're doing this temperature per hour, it looks as though 5 divided by 2 is what we're setting up, which really means we're increasing by 2.5 degrees per hour per unit of time. I don't really know if it's hour. Okay, and that's really it. So you should be able to calculate the slope given 2 points, and you should be able to calculate the slope giving a table. And that's it. Good luck on your homework.